Hello students, welcome back to another lecture in a series of lectures on classical mechanics, and this happens to be the lecture number 4. In the previous 3 lectures we have seen an overview about the 2-year MSc program, followed by the details on the syllabus that we are going to follow in this particular course, and then after that we have seen the requirement about the first chapter, namely the Hamilton's principle. And in order to understand the Hamilton's principle, we said that we need to know something about the dynamical system and a certain terminology. In this regard, we have seen in the last class especially, we have seen what is meant by generalized coordinate and what is meant by generalized velocity. So that is the place I think we have stopped in the last class. And if you can refresh your memory, we have used the symbol Q. So Q will be the general symbol for the generalized coordinate. And then if you take the time derivative, and the time derivative is denoted by a dot. So the dot notation is the one which we are going to follow. So we will not be writing dq by dt. So the point to be noted is that q dot is basically the meaning of dq dot will be equal to dq by dt. So we can avoid the writing of dq by dt and we can simply write down q dot. So writing is also comfortable, reading q dot is also comfortable, but the important point is that dot represent only time derivative. In case if you are going to put a q dash, for example, this can represent any other derivative, not necessarily, this is not a time derivative. For example, this can represent anything like dq by dx. It can be, I'm not saying it is always dq by dx, it can be dq by dx or it can be with respect to any other variable, dq by d. So here you can write down x, y, z, etc. So in this particular place you can fill whatever variable that depends on the nature of the q. Okay, so with respect to any other variable is what I mean by putting a box here, and here you see that it is particularly time. So I want to distinguish between the dot notation and a prime notation. So this is the prime notation and this one is the dot notation. So dot notation is only reserved for time derivatives, and the prime notation or dash notation is used for differentiation with respect to any other variable. So which variable, that right now we do not know, that depends on problem to problem, things will change. Okay, so this is what we have done in the last class, that what is meant by generalized coordinate and what is meant by generalized velocity. So these are the things that we have seen, and before proceeding further, let us also discuss an introduction to what is meant by a dynamical system, because basically this particular classical mechanics is basically a mathematical formulation of a dynamical system. So as I already told you that we are not going to start with the Newton's equation of motion and then solve a problem. That is not the objective. That is already done in the BSc course. So the MSc course on classical mechanics is basically a mathematical formulation of the dynamical system. That is exactly what is going on here. And two of the great mathematicians are involved in the development of the subject. So one is the Lagrange. So let me write down this. So one is the Lagrange is once again mathematician. The second mathematician involved in this particular the development of the subject is the Hamilton. So their developments or their contribution to the development of the subject is known as Lagrangian Dynamics, and correspondingly the second one is known as Hamiltonian Dynamics. So basically what is this Lagrangian Dynamics and Hamiltonian Dynamics is basically they are the mathematical foundations. Mathematical foundation means based on this particular foundation Newton's law exists, because Newton's law is an experimental observation, it doesn't have a foundation. So the question that we initially asked is, what is the foundation on which the Newton's law is standing? The answer is that Hamilton's principle. But Hamilton's principle, you see, once again you see this is the person, so Hamilton's principle, and the principle is a mathematical principle. So ultimate answer to the question is that there exists a mathematical principle which works behind the scene, and that is exactly the Hamilton's principle. To understand the Hamilton's principle, we need to have a proper way of defining a dynamical system. That is exactly what I have been telling in the last class also. So let us therefore move further to understand the meaning of dynamical system. And once we have the meaning, naturally these two symbols q and q dot we will be using there, and naturally we can see what is happening. So let me first of all erase this side of the board. Okay, so we are going to have some kind of mathematical definition for the dynamical system. And to start with, first of all, a dynamical system is not necessarily a physical system. It is not necessary. Otherwise, we can use a different name. For example, you can say it is a mechanical system, or you can say that it is a quantum dynamical system, or you can say that this is a statistical dynamical system. Okay, some kind of name like this can be used. Or in general, for a simplicity, we can at least use mechanical system. Okay, what is the point in using the word dynamical system rather than mechanical system is that dynamical system refers to a much more broader class of problems than the previous one. That means mechanical one. So mechanical one means specifically it is restricted to any physical system that is mechanical in nature. Okay, that means some moving parts are there, some object is there. So whatever it is, in the case of the mechanical system, means that it should be restricted to a physical system. Dynamical system is not like that. It can go out of physics. Completely it can go out of physics, and you can have a system for which there are certain time variations. The meaning of dynamical here, let me once again tell you that the word here, the dynamical, represents that there are time variations are there. Time variation means certain quantities are changing with respect to the time. That is the meaning. So dynamical represent time variation of something. It can be anything. That is what we mean to say. It could be anything. As an example, what do you mean by saying anything? And then what do you mean by saying that a certain system going out of physics, for example? It will be better if you can understand in terms of a specific example. Okay. So as a specific example, consider this particular situation. If you're going to have a group of cat, okay, and then you have a group of rat. So instead of saying rat, I can also use an alternate word, for example, mouse or mice. Okay, singular, plural, or whatever it is. So any of these words can be used in particular. So let us use the word mouse, for example. Okay, let me use the word mouse. Now, what is this combination that we are going to have is that assume that in a certain region of space, okay, in some geographical region, there is a certain number of cat together with a certain number of mouse. It's living in some region. Okay, so everything is a living species, and therefore they are living in certain region, and we make an assumption that the cat is going to survive. So the survival of the cat is going to depend on the by that is the survival of the cat is due to the eating of the mouse. That means that is its food actually. So let us assume that that is the only thing for it. Okay, it doesn't eat anything else. That is an assumption let us make for simplicity. So if you make that particular assumption, then what is the point to be noted here is that you are going to consider the population of cat and the population of mouse. Consider the population of both the species. Now, let us assume that both of them are of the equal value or any number. It doesn't matter how do you start with. So let us have certain number of cats and a certain number of mouses living in some region. That's all. Okay, consider the population of cat and rat in some region of space. And then what is actually happening now, if you think, the cat will start catching the mouse and then start eating it. So because of that, the cat is surviving. So that is what is happening. And due to that, what is happening is that the population of the mouse will come down. It will come down because the cat is catching this and then eating away day by day, and therefore it reduces the number of mouse that is present in a region will be reducing. Of course, there will be some additional population due to the reproduction, so that is there. But even then, the number of cats which are hunting this particular mouse will be large when compared to the reproduction, for example. Then ultimately what happens is that there will be a considerable reduction. So I'll put it down here or here. There will be a reduction in the population of the mouse. So I'll put double arrow here. So once again I'll put arrow here. So day by day this is decreasing. That is what I mean to say by putting two down arrows here. So day by day what happens is that the number of mouse that is present in a region is decreasing because more number of cat is coming and eating away them. So okay, this is going on. After that, what will happen? After some time, what happens is that the population of the mouse has come down greatly, that it has a very little population. Then what will happen is when the population of the mouse is very little, these cats cannot find it because anyway it will hide, right? This mouse will hide automatically. It will not come and stand in front of the cat, right? So mouse will always hide. Even after hiding, the cat is going to find it. That is what is the hunting is taking place. Now, since the population of the mouse is so small or so little that cat is unable to find it, it can't find where is the location of the mouse. So therefore what happens is, since cat is unable to hunt the mouse, what happens is cat slowly start to die away because there is nothing is there to eat, and therefore the population of the cat comes down. So that coming down is what I am showing by a down arrow here. So why this is coming down is because nothing is there to eat. Nothing is there means no mouse is there to eat, and therefore the cat starts to die away, and therefore the population starts to begin. Then what happens? This is what is happening, and then it keeps dying every day because nothing is there to eat. Now when this happens, then what happens is, since the population of the cat has come down, now this has come down, cat has come down, that means nobody is there to eat the mouse. Now, since you see here, the population of the cat has come down. If the population of the cat has come down, nobody is there to eat the mouse. And therefore, what happens is, now the population of the mouse will increase because number of cats has gone down, so nobody is there to eat, and therefore the population of the mouse will start increasing, and then it will fluctuate as time changes. So finally, our conclusion is the following. Our conclusion is, I am explaining this something here. Time variation of something means, as you can see, that the population increases. So for example, if m is the mouse, for example, if m is the mouse, let me represent, then the time variation means d by dt. So that is what is changing. Time variation means with respect to the time, dm by dt. So dm by dt will increase. So it will increase. So let me write down that this is greater than 0. Here I can say that dm by dt less than 0. So it decreases. So this is how you can schematically, or you can represent them in terms of mathematical language. So similarly, if you are going to write C is the population, we can also represent it by dz by dt. So you get an idea of a dynamical system. So this is an example of a dynamical system which is not at all related to a physics, for example. It is not related to chemistry or whatever. It doesn't fall into the usual physical system. Okay, physical system, thermodynamic, magnetic system. It doesn't belong to any of them. That's what I mean to say. It goes out of physics, and then this is an example. Similarly, there are many other examples are there. So we will not go into that because that is not our aim. Another example, for example, is financial dynamics. So financial dynamics, we will not enter into what it is, but the situation is something very similar to this. So ultimately, we are able to understand the meaning of dynamical system, and especially I have given this example in order to demonstrate why we have used the word dynamical instead of mechanical. That is exactly what I am trying to say. Otherwise, I would have written here mechanical system. Okay, by the word dynamical system, we mean to talk about more variety of problems which are going beyond physics. That is exactly the meaning of using the word dynamical there. Okay, that's all about it. And then let us go further and then go into the mathematical representation of a dynamical system. So let me erase this portion of the board. So we are interested in going for a mathematical definition. By the way, all the things are mathematical in nature. So I have already informed in the very beginning of this class that the entire MSc program that you are going to study, starting from mathematical methods, classical mechanics, quantum mechanics 1 and quantum mechanics 2, statistical mechanics, electrodynamics, solid state physics. Okay, whatever name that you are going to tell, nuclear physics, for example, particle physics, relativity, and cosmology, astrophysics, whatever paper that you are going to study in the list that I have said is completely mathematical in nature. So therefore, so this point should be very clear to you that other than experiment, okay, you are going to do some experiments in the laboratory. Other than that, everything is going to be mathematical in nature. Okay, the basic introduction, basic understanding of what it is, okay, everything. So those things you have completed in BSc. So in the case of the MSc thing or the master degree program, the whole thing is based on the mathematical foundation of what you have already studied in your BSc. So this is the this particular information should be clear to you so that you will be able to justify the importance of mathematics. Why mathematics is so important to understand physics. Okay, that's the point that I am trying to explain. For doing physics or for doing an experiment, for example, a considerable mathematics is maybe sufficient. Okay, but if you want to understand why these things are happening, why are the things the way they are, if you are going to ask that question, then you need quite a lot of mathematics to understand, because all the physical principles are working based on some mathematical principle. This is the ultimate conclusion. Every one of the physical principle that you are going to show or you are going to identify, those physical principles will have certain mathematical principles working behind the scenes. Okay, that is the reason why mathematics is very much required in order to understand the physics. In a simple language, we can ask the question, why are the things the way they are? That is the question. Okay, so let us now come to a particular situation here that we need to have a mathematical definition for a dynamical system. Okay, let us consider a two-dimensional situation. Two-dimensional means you have x direction, y direction. Then we can have for the one variable can be x here, and the another variable can be y. Just in the case of the cat-rat system, C will be the cat, for example, and R will be rat. So there are two of the objects are there. So that is an example of a two-dimensional system. So in a generic situation, we will be using x and y. Now, since we are talking about the dynamics of this particular variable, we need to have time derivatives. So let us put the time derivative. So time derivative means I am going to put a dot here. X dot means dx by dt. Similarly, let me write down that this is y dot is dy by dt. So I will be having the time evolution of, we can either say time variation or you can say it is time evolution. Time evolution is a better word. Maybe I will write down here. Time evolution of x, that is what is represented by x dot. And similarly, you have y dot. So now dynamical system is given by like this mathematically. X dot will be equal to, in general, any of the dynamical system can be written in this particular way. So this can be written down like this: a times x plus b times y. And this will be equal to a and b are two constants or two parameters. So two parameters are over. So take another parameter. Let it be c times x, for example, plus d times y. So you will be able to write. So let me put a bracket here like this, representing that this is a coupled equation, and this will represent this particular thing. It will represent a linear dynamical system. So this is very important. The word linear is there here. Let me explain that as we go along. So this is the basic definition, that how do you define a mathematical, how do you give a mathematical definition of a dynamical system? The answer is this. If x and y are the two variables which are varying with respect to the time, then the time evolution of the two species x and y will be governed by the equations that are written down here. And we say that this is equation number 1. Let me put the equation number on the left hand side. Okay, so that is your equation number 1. So the answer is clear. This is the answer. A mathematical definition of a dynamical system for which there are two variables x and y that are varying with respect to time will be governed by the set of equations given by equation number 1. This is the statement of the dynamical system. We will understand what it is, and we will also understand why the equations are written like this. I will also explain you why the word linear is written here. So let me explain now the next line. So let me erase this portion. So here, first thing is there are certain things that are to be understood here. So the first equation being x dot here is basically a dx by dt. So dx by dt is what is written down as a times x plus b times y. That is what we mean to say. And the second thing, y dot, this I am writing because first time you are learning the dot notation. Okay, so if I remove the dot notation and write down the full notation, namely the dx by dt, then you will feel comfortable. That's why I am writing. Otherwise, there is no need to write the same equation once again. Okay, so let me write down the second one. Similarly, the dy by dt will be written down as some other parameters times x plus another parameter times y. This is especially valid for a two-dimensional system. That's what I already told you, because x and y are the two elements are there. So there is one unknown quantity and there is another unknown quantity. Only two of them. That is why it is 2D. Suppose if you are going to discuss about three-dimensional dynamical system, then you will be having three equations. Okay, that right now will not worry about it. But remember that there will be three equations. X dot, first equation. Y dot will be second equation. You have to write one more equation with z dot. And similarly, on the right hand side, you should have ax plus by plus cz. One more term for z should be there. And similarly, this should be cde. Then three more should be written down. So that is an extension for the three-dimensional case. So right now you don't have to worry. If you understand for two dimension, the extension to three dimension is possible, and reducing and coming down to one dimension is also easy. So this is an understanding. Now there are two things that we have to understand further. What is the meaning of the word linear that is written, or why it is written? That is first question. Second question is why this bracket is there. So why do you want to put a bracket like this there? So these are the two things that we need to understand. So before understanding these two things, first of all, you have to realize what type of equation is this. So this is an equation. You have to classify the equations into an algebraic equation, differential equation, integral equation, integral differential equation, trigonometric equation, or a transcendental equation. Like this, you have a variety of equations are there. Under which category? These two equations, I mean to say that equation 1, for example. This is an equation 1. It is not a single equation, by the way. It is a set of two equations as shown in the bracket. Now this set of equation is coming under differential equation. So I have listed out, starting from algebraic, differential, trigonometric, okay, transcendental, pure trigonometric. There, like this, if you are going to show a set of names, then you will be choosing the name differential equation. So that is the first point that you are able to identify. So the given equation is a differential equation. So that should be clear, because derivatives are involved here. This is very important. You have to first classify whether it is a pure algebraic equation, or a pure integral equation, or a pure integral differential equation, etc. So our conclusion is that the appearance clearly tells you that this particular set belongs to a differential equation. I will also explain a formal way of defining differential equation. So first point is clear. Second point is that why this particular bracket here is there is that this is not only a simple differential equation, but this is also a coupled one. So I'll write down that this is a coupled differential equation. Differential equation is fine, but the purpose of putting a bracket here is that it is not a independently, it cannot stand. Okay, you can't have two equations that will stay independent of each other. That's not possible. One equation depends on the other one. That is the meaning of coupled. So the question naturally comes, how do you know? How do we know that this is coupled equation? So that can be seen easily. So how you can see that, let me explain you. Now let us explain this. Now when you have this dx by dt, when you write like this, first thing that should be clear to you is the one that you are going to write in the denominator is the independent variable. You have to write the independent variable only in the denominator. You can't write in the numerator. Okay. If you are going to write something in the numerator like this, dx that you are written, that should be a dependent variable. So this is the first point that you should know. This cannot be interchanged. Dependent variable will come only in the numerator. Independent variable will come only in the denominator. It's a standard rule. It has to come like that. This is the first point you should know. Second point is, what is the meaning? What do you mean by dependent and independent? By that, how can I understand in an experiment? Because when I'm performing some experiment in the laboratory, which variable is dependent, which variable is independent, how do I know that? So that should be clear. If this is clear only, you can also understand the meaning of the derivative. So let me therefore explain a simple situation that you are doing in an experiment. Let us say that you are having certain thermodynamic system with pressure, temperature, and then a volume. Usually you are quite familiar with them. You can always measure the pressure of the air. You can always measure the temperature of the air. You can always measure the volume of the room. You can measure the volume of room or a glass bottle, for example, or your water bottle. 1 liter water bottle is there. So you are measuring the volume. So pressure, volume, and temperature. These are the three variables that you have. Now the question is, which one will be dependent variable? Which one can be independent variable? That is the question. The answer is that it depends on what are you going to control. So the answer is this. The answer will come like this. Which variable are you planning to control? Because you are going to do the experiment, so you have to tell what are you going to control and what are you going to measure. So if you are going to control certain variables and you are also going to measure some variables, in an experiment, that's what you do. At least you know that you are going to do measurement in the laboratory. But before you measure, you have to control something. Without controlling nothing, you can't measure anything. So basically what you are going to do is, suppose if you are going to do certain experiment in an open air means without a closed room structure, okay, then what is happening? Indirectly, what is the meaning is that the P is constant. Okay, this is a simple situation. If you're, let us say that you are going to do an experiment on simple pendulum. You go to the laboratory and then take a pendulum and oscillate. And by that, what is held constant indirectly? You are not struggling to measure it, but indirectly something is constant, namely the atmospheric pressure is constant. Which means that you can control to keep a pressure to be 1 atmosphere, for example. You can repeat the experiment. This is the first experiment, okay? It is already constant, 1 atmosphere, that is clear. After that, what will happen? After that, you can change the pressure of the room to a lower value or higher value. If you evacuate the room, for example, then the pressure will come down. Or if you inject more gas, for example, in a closed room, then pressure will increase. So that is called controlling. Controlling means you fix a particular value of P. You fix it as 1 atmosphere, you fix it as 2 atmosphere, or you fix it as 0.5 atmosphere. You have to fix it. How do you fix? That is an experience. You can evacuate or you can admit additional gas into the room. By that method, you can change the P. This is called controlling. So that means you are fixing. Either P is already held constant naturally, or you fix P, P value. P value means pressure. If you are going to do like that, that is called independent variable. So now this is clear that if you are going to do all these things, then our final understanding is that this particular variable will come to independent variable because you are controlling. It is not necessarily that you have to control only pressure. You can also control temperature. For example, usually that's what you do, right? In some experiments, you heat the particular heater. For example, you can have an electrical heater and then increase the current passing through the heater and then control the temperature 100 degrees centigrade, 110 degrees centigrade, 120 degrees centigrade. You fix it. How do you fix? Means you vary the current little bit, you increase, and then the temperature will increase to one particular value. And now as long as the current is fixed, temperature also will be constant. Then you increase the current, temperature will increase. That is how you do. So basically what you understand ultimately is that you are able to control some variable in the laboratory. Such variables are known as independent variables. Then what about the measurement? Measurement is that anything you measure. You can measure voltage, you can measure current, or you can measure the volume. Anything you measure, you can measure electrical resistance. You measure anything. So whatever you are going to measure, that will be a dependent variable. So it is clear that controlling variable is known as the independent variable. Measuring variable is known as dependent variable. And now if this particular information is clear and you come back to this equation number 1 now, this is your equation number 1, and if you are going to look at this, what are you controlling and what are you measuring? We can see that T is fixed. So this T is actually time, and the time, naturally what happens is you don't have to struggle and control. Naturally the time translates uniformly. Okay, it doesn't change in a non-uniform manner. Okay, linearly it changes. You can predict how much time is there. 60 seconds means the time gap between the first second and the time gap for the second is same. That is what I mean to say. So interestingly, there is nothing is there for you to control. It so happens naturally. So you just have to keep track of the time. By keeping track of the time, you say that you are controlling the time. And what are you measuring is x and y is what you are measuring. So x is the one that you are going to measure. Let me put a round here. Or you can measure the y. So what is x and y? X and y can represent position, for example. In the x direction, the position of a particle can be x. In the y direction, the position of the particle. This is one example. Sometime back we have seen the cat and rat example. X will represent the population of cat. Y will represent the population of rat at a particular time. So you can always wait for a time. No, you can say that after 1 month. That means you can calculate how many seconds are there. Basically, the calculations are done in only SI unit. So in 1 month, how many seconds are there? You say that much time. That is your T that you are going to measure. So our conclusion is that in the representation of standard representation dx by dt, x is the dependent variable that we are going to measure, and t happens to be, naturally it is going to be a control variable. Okay, that is the meaning. And once this meaning is clear, what is the point that I was explaining is, I want to explain you the meaning of coupled here. How do you know that this differential equation is coupled? Now for that, this information is required. The meaning of dependent and independent is required. Let me also give an alternate name for this. There is also another name for this independent and dependent variable that I am going to write now. Independent variable is also known as, or there is another name for that, is the known variables, or we say that known. I'll write down that this is a known quantity. Independent variable means it is known quantity always. Okay, and when you are going to say that it is a dependent variable, another name for a dependent variable will be unknown quantity. This is all. This is not a problem for you. You can always come back to this experimental situation and verify. Now, since you are going to fix the pressure in this experiment, you are going to fix 2 atmosphere. So you already know that 2 is the value. But you are going to measure the dependent variable. I am going to measure electrical resistivity. I don't know what is the value that is going to come unless you put the meter and measure, I will be knowing. But here, since I am controlling, I am going to fix the value as 2 atmosphere, and therefore P equal to 2 atmosphere is a known number. So there is one thing is known, there is another thing is unknown. That should be clear if you want to understand the coupled here. Now in this equation, namely equation number 1, so let me write down here, in the equation number 1, what is that you known and unknown, let me write down that known is the time t. There's only one. That's all. T is known to you. How it is known means that's what you are going to say at 8 o'clock, at 8 o'clock 5 minutes. You already know the time. At that particular time, I am going to measure what is the position of the particle which is moving. So one thing is known, another thing is unknown. What is unknown here? Let me write down that also. The unknown quantities are x comma y. So there are 2 unknowns are there, because of course this is a 2-dimensional problem. Okay, 2 unknowns are there, that's okay. And then known quantity is t. So these are variables. So variables are clear. So that's clear. And what about ABCD? There are something is there, some extra thing is there here. A comma B comma C and D. So that are there here, right? This one here B. This ABCD, they don't come under any variable. They are not variable. It is not independent variable. It is not dependent variable. It's not at all variable, first of all. So these ABCDs are known as parameters of the problem. By parameters of the problem, once again the meaning implied is that they are also known quantity. That is the meaning ultimately. So that means these things are also known. Either you say that it is known, or you understand that it is given. Suppose for you have to understand that it is given. You take a question paper and then the value of the ABCD will be given in the question paper. That's the meaning of that. Known quantity means at these time intervals the experiment is done, and we would like to know what is x and y. So now you have an idea about what is known quantity, what is unknown quantity, what is a parameter, and what is dependent and what is independent. If all these things are clear, now you come and ask the question, how many unknowns are there in equation 1? There are 2 unknowns are there, and therefore there are 2 equations are there. We can say that this particular equation will be 1a and this particular equation can be 1b. So ultimately you are having 2 equations because there are 2 unknowns are there. So that's fine. Mathematically it is agreeing. How do we know that it is coupled? That is, once again we are asking the question. To answer that question, now you come to the 1a equation. In 1a, what is there is dx by dt equal to ax plus by. So let me write down that 1a here so that I can explain you further. Consider 1a now. If you are going to have 1a, you have this expression dx by dt equal to ax plus by. Now how will you solve it? Or we can write like this. If we solve, let me write down this. If we solve this equation, we get y. That is the meaning, right? This is what I am trying to explain once again. If we solve means solving for what? Are you solving for x or are you solving for t? So I am going to solve for unknown quantity. Unknown quantity is x. Therefore, if we are going to solve this equation means we are going to get the value for x here, and therefore this particular y that I have written is wrong. So now it is clear that what will you get if you solve. If we solve this equation, because x is the dependent variable, we are supposed to get x. That is clear, but there is a if here. That is where the trouble comes now. You see that there is a if here. But can you solve? So what is the problem now in solving this equation is that now this is an unknown quantity. So this one is unknown. I will write down unk, okay, unknown. And there is also another x here. So that is also unknown. That's fine. Now what about this b, this particular y? Shall we consider this particular y as known quantity or unknown quantity? That is the question. It is not clear, right? As far as y is concerned, you have to go back and see this equation. The y appears here. This y appears here. What is the meaning of that? The meaning is y will be known if 1b is solved. Okay, so I'll write down that expression, that meaning here. Can you solve? That's what you have written. But can you solve? No, we can't do. Why we can't solve is that because why we can't solve is because there is a y here. On the RHS we have y which is unknown. If you know this y value, then it's fine. You can easily solve it, not a problem. But on the right hand side, you can follow the white color cursor, right? On the right hand side of this equation, there is a y here. This y is an unknown. Unknown means I don't know what is the number there. Without knowing what it is, what I can do? I don't know whether to integrate this particular expression. Even if you want to integrate, I need to know what is that quantity. Without knowing what it is, you can't do anything. So basically, since y is unknown quantity, you can't solve. That is the meaning. But can you solve means no, we can't solve. Then the question comes, you first of all bring y. Okay, you first of all bring y, then you substitute here, then you can solve. Then the question comes, how do you get y? How to get y? That is the question. Answer appears to be simple, that you have to solve 1b, equation number 1b. What is that 1b? The 1b is this, dy by dt will be equal to some c times x plus d times y. So how to get y? That is the question. The answer is here. Solve equation 1b, I will get. So this is the equation I will get. But once again, you ask the question, can you solve this? Same question you have to ask. Once again, you ask the question, but can you solve this? The answer is no. You can't solve this equation because in this equation y is unknown. That's okay. But what about this x? This particular x is unknown. Or we have to understand that the get from 1a. So equation number 1a will give you x value, and that is what you have to substitute here. So this thing you can fill only if you solve 1a, and this one you will be getting only if you solve 1b. But both of them we cannot solve. Ultimately, that is what is the answer. We can't solve 1a also, we can't solve 1b also, because one is depending on the other. That one is depending on the other should be clear to you. Is this point clear? Equation 1a, you see this equation 1a depends on y. Equation 1b depends on x. So one equation is depending on one variable, the other one is depending on other variable. In such a situation, we cannot solve both of them. 1a also cannot be solved, 1b also cannot be solved. And therefore, they have to be, and therefore, this set of equation is known as coupled. So this kind of situation is what is known as coupled. So I hope you are able to follow this, right? 1b depends on x. How do you write this? 1b depends on x. How am I writing like that? See, this is 1b. So this is 1b. So dy by dx. So that depends on means what? The solution of 1b depends on the availability of x. If x is available, yes, solution is also available. If x is not available, then you also can't solve it. That is the meaning. So dy by dx depends on x here. If you give me, or if somebody gives me the value for x, then I can solve. Otherwise, not possible. So that is the meaning of this particular statement. 1b depends on x. So ultimately what happens is that the set of equations that we have written down here, namely the combination of dx by dt and dy by dt, cannot be solved independent of each other. And therefore we put a bracket like this. You see this particular bracket I am talking about. So this bracket represents that this is a coupled differential equation. So this is the very important one. Concept is very important, and most of the differential equation in nature, they are coupled, and naturally the solution is not simple. Just now you have seen that it is not possible to solve independent of each other. You can't solve only one equation and then solve the problem. You can't take only one of them. You have to consider both the equations together. Together means at a time. At a time you have to consider the two equations and then find out a solution. That is possible. So that methodology is quite different. That is what I am trying to say. The methodology of solving requires an idea to consider both the equations simultaneously. That means together. So that technique is different from the standard technique that you are going to use to solve a single equation. That is what exactly I am trying to say, that the differential equation is coupled, and therefore the methodology of the solution is also going to be very different when compared to solving a single differential equation. This is very important point that you need to know. Okay, so ultimately our conclusion is this: if you are going to have a dynamical system in 2-dimension, then we will be having a set of two differential equations that are coupled. That's all. That's the conclusion. But then I didn't explain what do you mean by linear here. So there is one more term that I have to explain. What is this linearity? And for that, let me go back and explain some formal way of having a mathematical definition for the differential equation. See, once you have the proper way of defining a differential equation, understanding linearity, understanding the coupled differential equation, they become somewhat easier. So if you are going to proceed in a step-by-step manner. So therefore, let me now come back to the situation of explaining a formal way of or a formal mathematical way of defining a differential equation. I'm not going to go into the details as we do in a mathematics class, because that is not our aim, by the way. In a formal mathematics course, you will be studying more details about this. But at the same time, for the basic requirements to proceed further in classical mechanics, certain knowledge is required. So at least to that extent, I will explain the requirements of a differential equation. So this is a formal way of a formal mathematical way of defining. This is the definition goes like this. You have an independent variable. You already know these things. That's why I have explained all these things. If you do not know independent, dependent, measurement, control variable, etc., you have to refresh your memory and come back. Okay. Otherwise, if you are writing down the class notes, you can quickly verify, and most probably you will remember. But in case if you are not writing any notes, then it will be difficult, or most probably you will have a tendency to slowly forget as time changes. So okay, coming back to the situation, the definition of the differential equation goes like this. You have an independent variable x, I have a dependent variable y, and then I have a derivative of dependent variable. So let me write down that this is y prime, and the prime represents dy by dx. As I already explained, dot represent only time derivative. Prime will not represent time derivative, therefore prime is going to represent here dy by dx. Okay, so this is very simple. I have an independent variable, this one. I have a dependent variable. I have derivative of dependent variable. Okay, at least minimum I need y prime. You can always have y double prime, y triple prime, etc. But this is a minimum requirement. Once you have these three variables with you, and suppose if you have a relation between them, the relation between them is mathematically written as f of, that is what is known as a functional relation. Relation means any combination of that. That's the meaning. Relation between means any combination of, that is called a relation. So if you have a functional relation between these three variables, the standard way of writing that in a mathematical notation is that you write this f of this equal to 0. That equal to 0 means that you write any relation in such a way that all the right hand side is taken to the left hand side so that the right side becomes 0. That's the meaning. So let us consider the simplest example. What kind of combination? F means, you should remember, F means any kind of functional relationship. Relationship means combination. In whatever way you like, you combine them. What is that you want to combine? I want to combine x, I want to combine y, I want to combine y prime. You can combine in how many ways means you can combine in infinitely many ways. There are infinitely many possibilities in which you can combine these three terms. But the most simple one, or the simplest thing that you can do, is simply add them, and that's all. This is equal to 0. So this is an example of a functional relation. Functional relation means a relation between the three variables. The most simple equation. If you don't want this, you can always have another one. For example, xy plus y square plus y prime into x equal to 0. This is another combination. The second one, this is also another example. This is example 2. Like this, you can generate an infinitely many number of relations are possible. And if you are going to have, or if you are going to write any one of them, whether it is the first example or the second example, or you can write down anything you like. For example, I can write down x plus sine y plus logarithm of y prime divided by x equal to 0. This is also a combination of independent variable, dependent variable, derivative of the dependent variable. I am having a combination of them. That's all. A functional relation between them. If you are going to have that, such a relation is known as, this is what is known as a differential equation. This is the formal mathematical way to define a first order differential equation. It's called a first order differential equation because you have only a single prime. If you are going to have a y double prime, then automatically it becomes a second order differential equation. So now you understand that these three, it's very easy to understand that this is a differential equation. This is another differential equation. This is yet another differential equation. So as you can see that generating differential equation or bringing the differential equation just like that is quite easy. You can write down an infinite combination of variables so that they all become differential equation. That's very simple. But writing down or bringing a differential equation could be simple, but what is difficult, or what is the most difficult task, is the solution. Solving the differential equation is going to be quite complicated, except for very simple cases of textbook problems. So only in the textbook you can solve the differential equation. Okay, in the case of the real life problems, solving the differential equation is not that simple. It's one of the most complicated problems is they solve a differential equation. So that is a different story. So now that is not our aim. So for the time being, I want to explain to you a formal way of defining a differential equation in a mathematical way. So this is the answer. The answer is this. If you have a functional relation between independent variable, dependent variable, derivative of the dependent variable, then such a relation, whatever be the relation, then all those relations are known as differential equations. So this is the first point. After this, once this is clear to you, I want to explain what is the difference between linear and nonlinear, linear differential equation and nonlinear differential equation. The rule is very simple. If you know this particular rule, it's quite simple to evaluate. For linear differential equation, one condition has to be satisfied, and the condition is this: the power of dependent variable must be equal to exactly 1. So that is why I have first of all explained what is dependent and what is independent. You should know which is dependent and which is independent. If you are unable to distinguish the difference between the dependent and independent, then that's all. you are out. You can't do anything. So first of all, you have to identify which is dependent variable. I have been telling in this expression that this first one is an independent variable that we are going to represent like this, and this one will be a dependent variable. Then this will be the derivative of the dependent variable. So for linearity means linear differential equation. What is the demanding condition is that the power of the dependent variable should be equal to exactly 1. Exact 1 is very important. Approximately equal to 1 is not accepted. Okay, approximately equal to 1 means something like 0.95 or something like 1.07. Such numbers are not acceptable. They become non-linear. So if it is exactly 1, only then this is linear. Other than 1, anything is non-linear. You can have 1.07, you can have 1.91, you can have 2, power 2, power 3, etc. Anything, whatever you write, they are all non-linear. So that is why I have written here this is exact 1. Exactly 1. Okay, no fractions are allowed. If there is a power of 1.5, no, it is non-linear. Okay, let us now come back to an example here. This is an example that I have written here. So tell me, what is the power of dependent variable? Is this dependent variable? No. You see that the x is an independent variable. Therefore, x is an independent variable. Forget about it. Okay, then come to the next term. Next term is y. Y is dependent? Yes, this is dependent. What is the power for y? Now, the y to the power 1, that's what is there. And therefore, this is linear. This particular term is linear. Come to the y prime. Y prime is also dependent, right? It is derivative of dependent, but ultimately it is also dependent variable. So therefore what happens is y prime, what is the power? The power is to the power 1, y prime to the power 1. So therefore this is also linear. So there is a linear term, this is also linear term. This one no need to consider, so reject it. We are not at all interested. And therefore linear term plus linear term will give you linear term only. Therefore we make an important conclusion that this is a linear differential equation. Come to this particular case, you have x into y. Now x, what happens is, x is not at all dependent variable, so forget about it. You simply don't want it, you can reject. And what is left out is y. What is the power for y? 1. So exactly 1. So this is linear. Come to this y to the power 2. So y to the power 2 is there. What is the power? 2 is there. So this is non-linear. Now one term, when it becomes non-linear, and that's all. You don't have to do any more checking. So this is the place where nonlinearity comes into existence. And therefore, we will make an immediate conclusion that this is an example of a nonlinear differential equation. You can ask the question, why don't you check this term? We will not check, because the moment you have a nonlinearity entering into picture, finally the total differential equation is nonlinear. It is like this, see, in the BSc first year, you study 5 papers. The BSc second year again, some 6 papers you study, and then final year BSc again you study some 7 papers. Like that you will be studying many theory papers and practical papers. And if you are going to fail in any one paper, okay, when I am reading this first paper pass, second paper pass, third paper pass, fourth paper fail, the moment you say fourth paper fail, I will not read fifth paper is pass or fail. I will make a declaration that you failed. That is the meaning. So that's how you make it. This, the moment you see a nonlinear term here, you immediately declare that that particular differential equation is nonlinear. You don't have to worry about any other terms that are there in the system. Fine. So that is clear. Now come back to another example. This is the third example. The first term is an independent variable. We don't want it, so throw it. Second term is sin y. Now the doubt comes, how to take power? Can I say that sin y to the power y? Can you write sin y to the power 1? Oh, it is power 1. Can you say like that? If you say like that, then you are wrong. This is wrong. Because we should not consider sin y to the power. You see, it's power of. I didn't say it is sine of the power of. Okay. Therefore, you should be very careful. Sin y is different. Therefore, we will now come back and ask the question, what to do for sin y? So for that, what you do is, you again go back to a very simple you already know the infinite expression, right? I mean the power expansion, power series expansion, I mean to say. So you know that the sine theta is approximately something like y minus y cube by 3 factorial, something like this is there, one formula is there, and you'll have to verify whatever be the formula, some formula is there. I'm not interested in exact formula. What I wanted to tell you is that this particular term is power 1. This is power 1. I'll write here, this is power 1. Now this one, we say that power is not equal to 1. I am not interested to say that power is 3 here, power is 5 here. That I am not interested. I want to say whether power is 1 or not. If it is 1, okay. Otherwise you say no. So since power is not equal to 1, so automatically this means this is non-linear. Because you have a linear term, so the first term is linear term, second term is a non-linear term. So you are going to add a linear term plus non-linear term. If you add them, what will you get? The answer is you will always get non-linear term. It is like, one paper pass and one paper fail. Final result is fail only. Okay, that is a combination that you will be getting. And therefore what happens is, the sine y, the moment you see a sine y here, this is a non-linear. So our conclusion is that this is non-linear. In fact, if you come to the last term here, you see logarithm of y prime by x, but this x again is independent variable, so totally we don't want to throw it. I have logarithm of y. Logarithm is again, you remember, logarithm can be expanded as an infinite power series. Now the moment you are going to write a power series, the powers are not going to be one. You will be having different powers, so automatically it's also non-linear. Okay, so finally what happens is, this is also non-linear, that is also non-linear. Ultimate conclusion is that this particular equation is also a non-linear differential equation. So this particular thing that I have explained till now is going to be very important one. It is very basic. Remember that this is most fundamental and basic. At the same time, it's very important. If this clarity is not there for you to distinguish between a linear and a non-linear differential equation, if you don't have a capability to distinguish the independent variable and dependent variable, or if you don't know how to distinguish between coupled equation and uncoupled equation, and then you are going to make a big mess around in the equations, you don't know what you're writing, that kind of situation will come. So you have to be more careful. Fundamentals are very important, and that's why I am also explaining. I can always make an assumption that you already studied in maths department some of these things. Certainly you must have studied, but I don't want to make an assumption that you know all these things and then straight away jump into the mathematics of dynamical system. But instead of that, I would like to take some time and explain some of the basic concepts that are very important. And in continuation, I would like to explain in the next class how to write this particular dynamical system equation in a coupled form, in a way in which you can solve. Okay, now the way in which we have written is this one. This is the way in which we have written. Now this particular appearance is not comfortable for the solution, so you have to rewrite this equation in another form. Only in that form you can solve. So in the next class I will explain you how to write in that particular form, and after that we will quickly go into our main topic. Our main topic is to explain the Hamilton's principle. Okay, so to know the Hamilton's principle, something about all these terminologies are required. That is why I'm explaining. So let us see in the next class more about how to write the governing equation for a dynamical system in a form that is suitable for the solution, and from there we will move along to defining further details towards the Hamilton's principle. That we will do in the next class.